Hi, my name is Quek. I'm a software engineer at Genentech. I am part of a very innovative team developing and maintaining bioinformatics platform on the cloud. We have been adopting and exploring the use of AI and agents to automate and streamline operations of our platform. And today I'll be sharing some of the applications and the lessons that we learned along the way, and I hope you'll find it useful. So just a bit about myself. I like to build bioinformatics platform. I've been doing this for a while now. Started out at DNA Nexus and then move on to Freenome, AWS, and then now I am Genentech for a few years. Um, and going back to the agenda of my talk, initially I was just going to share the stuff that we have been building and using on our platform. But when I was asked by our head of technical innovation, Sarah Magoo, about what is the most important message that I would like to share today, and it really got me thinking that maybe a show and tell would be nice, but everybody is already building some sort of awesome agentic system out there. And I don't think this is the most valuable lessons that I can share with you today. And so I was thinking, and I remember a story and an advice from my colleague, Sean, and he's very philosophical about software engineering. And when we met Ona, which is the platform where our background agents is running right now, we asked the folks from Ona, like, what is the meaning of the name? Like, why is Ona called Ona? And they told us that it is because Ona is the name that the founder wanted to give his child. He never had a kid, so now he's calling the platform Ona instead. And if I remember correctly, the philosophy is that Ona will be the platform that will be secure and safe for engineers to build technologies and run agentic system like what we are doing today. Much like a safe home where a child gets to grow and learn to be free. And so I think this is actually the most important message that I would like to share today. We are a small team in Genentech, which is a huge biotech company. And when we started adopting agents in our team, we needed a safe space to operate on. And Ona was a good environment for us to begin. And then we started small. We started with just using agents for doing operation kind of work, monitoring our system, triaging issues, nothing too fancy. And the more that we learned, the more confident that we became. We started doing more, and we moved to having it do development for us. We are now at a point that we're so confident and comfortable with the platform, with the agent, with the system that we have provided it, that we're asking the agent to do some sort of self-evaluation and self-evolution. So in other words, I think by the end of my talk, you will be able to know that the most important message that I'd like to share is that you should choose the right environment, start small, grow, and do awesome stuff. And so before I can continue talking more about the agents that we have built, I need to give you a quick introduction to genomics. Genomics is the study of genetic material in a living organism or in biology. And it usually starts with collecting biological samples, passing it through instruments like a sequencer, which will produce a bunch of raw results. And those results will be fed into what we call a genomics pipeline to produce results that is analysis ready. Genomic pipelines is not your typical data pipeline. It comprises mainly of a bunch of different open source tools from different research labs, different groups around the world, which is kind of different from your standard ETL pipelines where you have the opportunity to choose to use one single framework from start to end. And therefore, the language that is used within a genomic pipeline could be a mix of Python code, R script, C++ binaries. So it gets a bit complicated. Likewise, because these are different tools bundled together, you have a wide range of file formats that could be very domain specific. And you can imagine if you have such different software, they will be written by different developers, different places. Error handling and failure reporting can be very different. And in other words, when you're running a genomics pipeline platform, you need to have a mix of both domain and engineering background. Another challenge or attribute of genomics pipeline or the genomics problem in general, that it is an exabyte scale problem. So NIH in 2022 estimate that by 2025 we'll have 40 exabytes of data worldwide. I do not have the actual number right now, but we can all agree that this is a huge data problem. So when you have huge data, you need a platform that scales. So we are running most of our or all of our analysis right now on AWS. We try to keep our infrastructure simple, and we are very happy that it scales pretty well. However, the cloud infrastructure is not how our user will interact with our platform. They are not going to AWS, for instance, to start their own run directly on a console or through the CLI. Instead, what we do is we build web applications whereby a scientist can easily click a button and then it will start the job in the cloud. And this could be ranging from a few EC2 instances to hundreds, or even for the larger scales studies, thousands, if not tens of thousands of instances in the cloud. Most of the time, things goes well, but things can go wrong. And when things goes wrong, before we have our agents helping us, a troubleshooting cycle looks something like this. The engineer will first go in, try the ticket, check our runbook if this is something that is known, and try to figure out what is wrong. And if it still can't figure out, if we still can't figure out what's wrong, we go through this escalation loop whereby we will ask AWS support if it's an infrastructure issue, or go to the bioinformatics engineer who wrote the workflow, like, why is this failing? And then the bioinformatics engineer might go to the scientist and ask, is this a biological failure? So there's an escalation loop that could take anything from hours to days, or in the worst case, weeks. Now with Agent, you can actually have the domain experts to encode their knowledge in documents, in skills, in agents, in runbooks. And when you feed this all to an agent and let it and provide the environment for it to do whatever it needs to, like by connecting it to our AWS account with the correct appropriate permissions, connecting to our application where the workflows are running, the Confluence page, our database, etc. And if you really allow it to do what it needs to, and provide the environment for it to perform, you can actually accomplish a lot. And how we are troubleshooting tickets analysis right now is simply asking owner or the bot on my research fail, my analysis fail, can you tell me why? And it will just go through the entire troubleshooting process. And this really reduced the time needed for us to figure out what is wrong with the analysis from hours, days, to just maybe minutes or within an hour. And when we look at, and in addition to just figuring out what is wrong with a single analysis, you can actually ask it to also do like a larger incident report. In this case, we have a workflow that was really trashing the file system that we have because we are under provisioning for this specific workload. We have not seen this workflow before. This is something new. And then the alarm got triggered. Owner came in and did some triaging. The engineers came in and also tried to figure out what is wrong. And eventually we were able to resolve the issue within an hour. And the most incredible is that you can have agents write really nice incident report if you give it some sort of instructions on how to do it, like a skills. And this is something that would have taken me days or if not weeks to prepare. And of course, you can have agents are really good at generating content, so very good at generating even more reports. We are now generating operation logs or daily summary of the platform, and this really free us up time on ops review. Like in the past, we might spend a week, an hour or two to figure out how the platform is working. Right now, it's just reports that get sent out daily. And if you look at the right, we send a report out to Slack, and then underneath we have discussion about the runs that failed, how can we prevent this, how can we fix this, etc. And of course, Spring Report is something that you can generate quite easily with agents these days. But something that I want to share is that now that we are getting really confident with the agent, with the platform, we started asking it to do even more. If you notice, we complete about 189 tickets for this sprint, which is about 4 times as much, or 2 to 3 times more than what we usually accomplish. We are a small team of 4 engineers, and the reason why we are doing more now is because we started asking owner to help us to clear some of the tickets or help us to start with some of the development itself. And this is because we started, again, back to the key message that I want to share today is start small. Like we have the ops, now we are confident, we start asking the bot to do development. And we are being very pragmatic here. We're not, too crazy. We don't spin out agent swarms. We don't let the agent run for weeks. Here we are just asking the bot to do exactly what we want it to do, which is to complete task for us, development task for us. So the engineers will prioritize the tickets that we want the bot to do, and every hour we will schedule a task for the agent to decide on what it wants to do. We have some sort of priority for it, but it will determine if it wants to clear one of the feature tickets or look up any existing PRs that it might have put out put out before. And so basically we let the agent decide on what to do, but we ensure that the environment that it is working on is safe and it allows him to accomplish what we want the bot to do. And we are allowing the bot to merge directly into our main branch because we have integration tests, unit tests, etc., canary tests, and we let all the changes bake in our test environment where there's a bit more traffic. And again, back to the team, whereby it's all about providing the correct environment so that the agent can perform what you want it to. So if we look at the 180 tickets, the bot completed about 122 tickets. A lot of them are like things like renovation changes, things that regular software engineers, we really hate doing. It also do code changes. You'll see that it does some sort of self-improvement. Of course, some of the diagnostic tickets that we do with the ops bot is also a ticket in our Spring bot. And this is just a screenshot of the process of what it's doing. Again, this is production. This is not some theoretical experiment that we're running. And you can see that it's putting in merge requests that get merged every hour or every 2 hours or a few hours. And how we are doing reviews right now, I think this is a common question that we get is if you're putting so much pull requests, if the bot is putting so much commits in, how do you review all these changes? And for right now, what we're doing is, in addition to all the tests, all the integration test canaries that we have, we're doing batch reviews to make sure that the changes that we intended, that's baking in test for a few days now, is actually exactly what we need. We also have the bot make sure that for most of the features that we're introducing, we ask it to have it implement with a feature flag so that if we really do not like the way that is being implemented, we'll just turn it on and off. And so I think this has been working fairly well right now. We have made several production release with these changes. Just a bit of disclaimer though, we are still in a research environment, like we are in a research team, so our environment is a bit more forgiving than say if you're in AWS and if you have a SLF 99s to upkeep, then maybe this is probably not the best approach. Yeah. So now that we have gained now that we have really learned how the agent works and we really have provided an environment that we're really comfortable for the agent to work on its own, we started asking it to do something that is a little bit more fun. And one of the reasons why we are able to do it is because now that the agent is helping us solve so much of our software engineering chores and jobs, we actually have more time to figure out some of these more interesting aspects of software engineering. And so we decided to let the bot, what if we just let the bot, start learning from its own sessions and try to do some sort of evolution along the way. And we know that this can work because it has been published a lot of times there's a lot of publication about it in general. And something that was really promising was a paper called MetaClaw, which basically shows that if you're using a frontier model and if you're evolving the skill over time, it can really improve the completion and the accuracy of the task it's being assigned to do. And in fact, it's even better than if you have an open model and then you do all sort of fine-tuning. Unfortunately, for the little guy, that frontier lab model with evolving skills is still outperforming, all the fancy fine-tuning that you are doing with a open model. So this looks very promising, and this is exactly the focus on what we are doing to improve our agent. So to improve an agent, there's a few ways you can do it, right? You can say improve the models, but that is something not our team is capable of doing right now, and something that is really resource intensive. We can let it figure out and evolve it on the harness level, but again, we want to make sure that our environment is safe, a place where you can do with tasks. So maybe on the harness level is not where we should be allowing it to self-improve on. But on the context level, your skills, your agent's MD, I think we are very comfortable with letting the agent figure out what it can do and what it cannot do. And that is exactly the current focus for our agent in doing its own evolution. So what we are doing right now is we are syncing our session logs to S3, and every night, just before it goes to bed, we ask the agent to look and reflect on what he has done today, and using some of the other information of the things that he's done in the past few weeks or past few days, and try to analyze what went well, just your typical reflection, and ask it to create new skills and document whatever he have learned onto a diary, which we are using Confluence for. So this is how it looks like. Every day, it will just report us on Slack, like the things that it learned, the tickets that it's created, ask us to review it. And we also keep a diary on Confluence. So we were curious on how well it was actually working. So we actually did a analysis, and we look at one matrix, which is the 2 calls per session. Essentially, we believe that if you provide enough context, the less 2 calls is needed by the agent to complete a task. So using this as a proxy of how efficient the skills have become, we plot it against the number of skills versus the 2 calls per session. And we notice that as the number of skills increases, the 2 calls reduces, which means that maybe the improvement in the context is helping the agent to figure out what it needs to do quicker and faster. And of course, we dig deeper down into the different skills and how that has been leading to improvement. And we realized that for most improved skills, it did result in huge improvement, but not all are the same. And in fact, there are certain cases whereby adding more skills did not help at all. Looking at those skills that did benefit from the evolution, things like your data management, your Jira management, operations. And this makes sense. If you ask a bot, an agent, to create a ticket on Jira, but you don't give it enough context, it will spend time trying to figure out the ID for the bot, the ID for the user, the type of tickets, the epic that it's supposed to go to. But if you give it enough context, then it does not have to go through all the different 2 calls to figure out the different information that it needs before it can create a ticket. So I think this makes perfect sense. But we're very curious about why, if we give it very specific, like why some of the workflow-specific debugging did not quite work. So we take one good thing about Owner is that everything is within Git, right? So you can actually just revert your code repository to where before the evolution begins, and then you can do comparison that way. And this is exactly what we did, and we did a before and after. We give them the same amount of task, and then we asked it to figure out what's wrong. And in both conditions, they were able to figure out what is wrong, and both condition gave the correct recommendation as well. As for specific error, it's more like a kind of like a blue score, like you have to get the exact name of the error. So that is not, even though semantically it could be the same error, but if it's not using a right word, then we mark it as, the specific error was not named, so we can ignore that matrix in this case. But what we realize is that for generic skills, what we realize is that by providing generic skills, it's usually good enough for it to figure out what is wrong with a failed job, for instance. However, for specific skills, because now it has a detailed checklist that it has to go through, it actually slows things down. And in the worst case scenario, we see that the agent is spending 2 times more to figure out what is wrong when the actual error is very trivial. It's just right there in the logs. If you have just trust the logs, the first time you see it, it will have got the underlying root cause correct. And of course, you can do a breakdown and you can see how long it takes for each steps along the way, like what it was doing when he was doing a debugging. And you do see that there is a bloat in the starting of the session where it's trying to fetch data and check the inputs, etc. And this is because now it has a checklist of things that it needs to fetch, or the checklist of things that it needs to prepare before it can start the diagnosis. And I think this is pretty cool, and this is helping us to figure out how we should be writing our skills so that they are more efficient. And so I think with that, I come to the end of my talk. And I hope that through our use case of starting up as an ops bot, moving into development, and then start doing some of the self-evolution, is kind of share the idea that we should start small, be pragmatic, and then eventually grow into something more complicated. The environment is very important. Whether it's just like us working in a company, the right environment will probably foster the right talent. And so right now, as a software engineer, with all the bots, all the agents helping us in the background, I can independently debug complex genomic issues. I spend less time debugging, more time to build. For the computational biologists, this means that they have more time to build more meaningful workflows. They don't get bugged by the software engineers as much now. And then they have more bandwidth to engage with the scientists to figure out what they want to analyze or build next. And as a scientist, I think this is providing a better experience. And with that, I would like to thank everyone in my team, some of them, and our users, and some of the different teams that we have been working with. Yeah, thank you very much. All right.